Let's find an absolute max and absolute min without even getting a picture of the graph. We're going to do that by first finding any critical numbers. That will tell us whether we have relative max or min, and then we're going to compare them to the end behavior. So taking the derivative of x squared minus 4, we're going to get 2x. We want to set that equal to 0. When you just have an mx plus b, if you just have x to the first, you want to just isolate x by itself. So all we need to do to this to solve is divide both sides by 2, or you might just recognize automatically 2 times something has to be 0, so that something must be 0. So either divide by 2, or you might just recognize x is 0 already from looking at the function. There's our critical number. Now we can make a sign chart and see whether this critical number is a relative max or relative min. But if we have our interval of interest, we don't even have to make a sign chart. We know we're interested in zooming in on this graph from -1 to 3, and the only possible high or low point on this graph is going to occur at the critical number 0. So you want to compare endpoints and any critical number in between. So if our critical number was 5, we wouldn't even have to test it because it's not on the interval from -1 to 3. But if it's on the interval of interest, we're going to test it. And we're going to see what's happening at our endpoints by plugging in to see their y values. So we're going to do -1 squared minus 4, plugging into the original function. And that is going to give us 1 minus 4 is -3. If we plug in 0 squared minus 4 into the original, that y value is -4. And then plugging in 3 squared minus 4, I'm going to get 9 minus 4 is 5. So we want to compare the y value of the critical numbers that are on the interval of interest with the endpoints of that interval. So we're looking at our 3 y values, -3, -4, and 5. And we want to figure out what ones are the absolute max and which ones are the absolute min. So first of all, this is our absolute max. Our absolute max value is 5. If it says absolute max point, we would write 3, 5. So value just means type in a y value or write in a y value. Point means write at x, y. And then between my 2 remaining points, which one's going to be the absolute min? -3, the other endpoint, or -4, my critical number? -4 is lower than -3, so my absolute min value is -4, or if you're asked for it as a point, you'd write absolute min point is 0, -4. So you can make a sign chart, but you don't have to as long as you have your 2 endpoints. So what this graph looks like could be determined with a sign chart. We're not normally going to make one because we don't have to. The 2 steps are to find critical numbers and then compare any critical numbers on the interval to the endpoints. But just to visualize this first one, if we make a sign chart quick, our critical number is 0. Made f prime 0. Plugging in a number before 0, -1 into the derivative. 2 times -1 is negative. So we are decreasing to start. And then after 0, plugging in a test value, you can plug in 1. 2 times 1 into the derivative is positive. So the sketch of the graph would be decreasing to a 0 derivative at our critical number to increasing. And what we just did here is we zoomed in on part of the graph. Here's my critical number. It's at the point 0, -4. And we're on a specific interval from -1 to 3. So this might be the point -1, -3. And this is the point 3, 5. So we zoomed in on this graph and we said, just looking at this interval of interest, where is our absolute max point and where is our absolute min point? So our absolute max ended up being at the end point to the right, and our relative min, which we could see from our sign chart, we had a relative min, also turned out to be an absolute min, just by comparing the endpoints. So without ever having a picture, what we really did was zoom in on a picture. And we could see our relative min is also an absolute min, and then we had an absolute max at that right endpoint. We're going to continue to do this in 2 steps, take the derivative, compare to the endpoints, and we won't typically draw a picture because we can get our answer without it just by looking at the y values. Highest y value is an absolute max, lowest y value is the absolute min.